2-5 day 2, yeah. Alright, so we are going to start today right here. And last week, we learned what to do when we get stuck with proofs that involve segments. And what you're gonna notice, particularly in this section, is that you also have things to do when you get stuck on angle proofs. And they're exactly the same. You're gonna notice there's the same steps with angles as there are with segments. So first of all, one of the things that's super common to do when you have angle proofs is you can take the squiggly off and add the little m's for measures. And that is called definition of congruent angles. Or you can take the m's off and add the squiggly, and that's also definition of congruent angles, okay? Then we have angle addition postulate. So last week we talked about the fact that sometimes we had a segment that had 3 points on it, and we could take and break our segments up into parts. And we could say like AB plus BC equals AC. Okay, so we took that segment and broke it into parts. You can do that same thing with an angle. It's a little bit of a pain in the butt because every time you name an angle, you have to use 3 letters. And we'll see today that sometimes you also have to worry about what order you put those letters in. But when you have this, you have angle CAB, which is this whole thing, equals angle CAD, which is this, plus angle DAB, which is this, okay? Anytime you take an angle and break it up into 2 parts, that is called angle addition postulate. Just like this one was called segment addition postulate. Okay, so I have some hints here. If you do get stuck on an angle proof, you can take the squiggly off and add the little m's, or you can break your angle up into parts using the angle addition postulate. And then once you do that, you're probably going to get stuck again. And remember that usually when you're stuck and you've done those things, then you're going to look at substitution. And always look at your proof statement to see what it is that you want to prove equal, and try to use substitution to get there, okay? So, we're gonna go over a couple of things. First of all, we have talked about reflexive, symmetric, and transitive. Those also work for congruent angles. So reflexive property is anytime something equals itself or is congruent to itself, okay? Symmetric property is, do you guys have this speech? Yeah, okay. Symmetric property is anytime you take something and flip the 2 sides, that is called symmetric property. And then transitive property, if the ending of this and the beginning of that are the same, you can cross those out and say that the outside 2 are congruent. And that's something we've talked about before. Now, these 2 theorems, if you just read them, they kind of sound confusing. It says, angles supplementary to the same angle or 2 congruent angles are congruent. But what this actually means is if you knew that angle 1 and 2 were supplementary, and let's say that they told you that angle 2 was 60 degrees, and you knew that angle 1 and 2 were supplementary, we could then say angle 1 has to be 120. Then if they also said angle 2 and angle 3 are supplementary, if 2 is 60, that tells us angle 3 has to also be 120. So what this is saying is if you have two angles supplementary to the same angle, the only way that's going to happen is if these two angles are equal, okay? And then it also works for complementary angles. So let's say that they told you that angle 5 was 70, and they said 4 and 5 are complementary. That means 4 would have to be 20. And then if they said 6 and 5 are also complementary, 6 would have to be 20. So if two angles are complementary to the same angle, the only way that's going to happen is if those two are equal or congruent. So sometimes in geometry what will happen is you'll be given a theorem and then you have to prove that theorem. So that's what we're going to do on this slide and the next slide is we're going to prove those two theorems I just went over, okay? So we're going to start, and notice we're given two things, and they listed both of them under statement 1. So this is going to be given. All right. Now, complementary means that the two angles are going to add up to 90. So what they did is because angle 1 and 3 are complementary, they said that the measure of angle 1 plus the measure of angle 3 equals 90. That is by something we haven't learned before. It's called definition of complementary angles. Now normally when we do a new step, I would make sure it's on your cheat sheet, but this step is not one we use again. We don't use it unless we're doing this particular proof, so you don't have to worry about remembering it. Then also because 2 and 3 are complementary, you can say those two angles add up to 90. Now, if we look at this next one, does anyone see how they got step 3? Anyone have a guess as to what they may have done? Do you guys see how these two sides are identical, okay, or the same? If those two sides are the same, does it make sense that those two sides would be equal? And that is substitution. So because the measure of angle 2 plus the measure of angle 3 is 90, you can take this and substitute it in for 90. So this is substitution property. Okay. Now, does anyone see what they did in step 4? Subtraction. Yes, they subtracted angle 3 from both sides. So that's SUBTR prop. Okay. And then for the last step, what they did is they took the M's off and they added the squiggly. That is definition of congruent angles. So whenever you take the M's off and add the squiggly, or take the squiggly off and add the little M's, that's definition of congruent angles. Okay. Now this is another one where we are proving one of the theorems we just went over. And this particular one has 3 givens, and they have them all again under step 1. So for step 1 here, we're just going to write given again. Okay. Now, do you guys remember on this proof, they told us two angles were complementary, and they added them together and said it was equal to 90, and we said that was definition of complementary angles. What do you think our reason would be here then? Yes, this would be definition of supplementary angles. Now, again, this step, I believe we only use in this proof, so you don't have to worry about remembering it, okay? Now, can you guys see how these two are equal? Doesn't that make these two equal, right? So I can go down, basically what they did here is they said, if the measure of angle 3 plus angle 4 is 180, I can put that in there, which is substitution property. Now, honestly, if I was doing this, I would have done step 4 right after step 1, okay? Because you guys right now would probably look at this and think, how did they get from here to here? And you can't really see how that is. But what they actually did is they took this and all they did is got rid of that squiggly and added the little m's. But that one would be hard to go back and see. You always tend to look at the one right before it. So what is that called? Very good. Definition of congruent angles. Okay. Now, do you guys see anything they did from here to here? And you can always look like measure of angle 1 stayed the same, measure of angle 2 stayed the same, 3 stayed the same, but they switched angle 4 to angle 1, right? So what did they do? Substitution. They took this angle 1 and substituted it in there. So that's substitution prop. Okay. Then do you guys see how they got step 6? They subtracted the measure of angle 1s. So that would be SUBTR prop. They subtracted the measure of angle 1s. Now what did they do when they take the m's off and add the squiggly? Definition of congruent angles. Okay? Now, let's go here. So this is a new theorem that we're going to use in this proof here, but then I don't believe we use it again until our next chapter. Just so you guys know, when we get done with chapter 2, we skip chapter 3 and we go right into chapter 4. And chapter 4 has proofs, quite a few of them. And those proofs I think are easier than what you're doing now. Okay? They're all kind of similar. You're trying to do the same thing in each proof. And to me, they're easier. Once you get through chapter 4, you're done with proofs. Okay, we don't do them anymore. There's proofs in our book. I just don't assign them after chapter 4. So this is something that you guys know, vertical angles theorem. We just never talked about it as being a theorem before. But if two angles are vertical, they're congruent. Do you guys remember vertical angles are when you have two lines that intersect? They're the angles that are across from one another. So like angle 1 is going to be congruent to angle 3, and angle 2 is going to be congruent to angle 4. This is listed in your cheat sheet. If you ever need to abbreviate, you can do vertical angles theorem like that, okay? So you can certainly use that, but like I said, we don't use this, I think, until chapter 4 after this proof that we're going to do right here, okay? Now this proof right here is actually a combination geometry and algebra proof. And the other thing I want to point out is in this proof we have an if-then statement. And I'm not sure if I talked about this enough, but the if part of the statement is what you're given. The then part is what you're trying to prove. So first our given would be that angle 1 and angle 2 are vertical angles. Okay. The second thing that we're given is that the measure of angle 1 is D minus 32. And then the third thing is that the measure of angle 2 is 175 minus 2D. Then, when you go to decide what you're going to prove, that's what's after then in your if-then statement. So what we're trying to prove here is that D equals 69. Okay? So now we're going to go down to our proof, and we have 3 different givens. So what I would do is write them all under step 1. So let's do that. Let's just copy those 3 givens. So we're going to say angle 1 and angle 2 are vertical angles. Then we're going to say the measure of angle 1 is D minus 32. And the measure of angle 2 is 175 minus 2D. And that is given. Okay? Now, if they give you vertical angles, that means you're going to use vertical angles theorem. Okay? And what they told us here is that angle 1 and angle 2 are vertical angles. So what we can say from that then is that angle 1 is congruent to angle 2. So let's come down here, and our step 2 would be that angle 1 is congruent to angle 2. And how we knew that is because of the vertical angles theorem. Okay, angle 1 is congruent to angle 2 by the vertical angles theorem. Now, what we eventually want to do is solve for D. So we're going to end up substituting in like D minus 32 in for the measure of angle 1. Right now I can't substitute that in because it's an angle. I have to switch that to the measure of angle 1. So I'm going to rewrite this as the measure of angle 1 equals the measure of angle 2, because now I can substitute in that. What is that called when you add the little m's and take off the squiggly? Of congruent angles. Very good. Now basically we just have to substitute in. Okay, so what I can do then is go back up, and I can take this and substitute that in for the measure of angle 1, and I can take this and substitute that in for the measure of angle 2. So what I would get then is D minus 32 would equal 175 minus 2D. Okay? And what I did there is substitution property. And SUBST and then prop. Now we're at an algebra proof and we want to solve for D. And remember, like, your D is on the left, so probably what's best is to bring your D's to the left right away. So when I do that, do you guys get that I'd want to add 2D to both sides to bring that 2D over? And D plus 2D is 3D. Minus 32 equals 175. And we added that 2D, so that's addition property. What would I do next? Add 32. So when I do that, I get 3D equals 207. And that is addition property again. And then what would our last step be? Divide. Very good. So we can say D equals 69, and that is by the division property. Okay? Now, this is a step that I did not put on your cheat sheet, and you guys have most of, if not all of, the back side of your cheat sheet blank, unless if you put something on there. But can you guys copy this onto that sheet? So I don't think I said this yet, but after today, we're done with the proofs for chapter 2. So then we spend 2 days, Tuesday and Wednesday, on section 2.7. And then next week we'll do 2.8 and 2.9 on Monday and Tuesday. And then on Wednesday, we'll do a practice quiz next week. And Thursday will be our quiz. We do instead of learning everything or testing everything, what's going to be on the test is everything since algebra proofs. So like law of syllogism, law of detachment, that won't be on the test. Okay? All right. Did I give you enough time? Okay. So what's going to happen, oh, and by the way, you guys, this should be an arrow. It's not a huge deal, but it should be. So what's going to happen next is we're going to have 2 proofs, and they're going to have bisectors in them, at least one. So when you have an angle bisector, what that means is it cuts the angle in half, okay? So what happens here is these 2 parts are congruent. So what you would say is then that angle ABD is congruent to angle DBC, and our reason is definition of angle bisector. That is something that we use and you may see in your assignment today. The last thing that somebody asked me today, and I've heard this from a couple people this chapter, so I think this is worth going over, is there's a couple people that get confused between transitive and subtraction. Transitive is anytime you have 2 separate equations and the ending of the first and the beginning of the second are the same, and you cross those out and say the outside 2 equal each other. Okay, that's transitive. Subtraction, you have 1 equation, and like CD would be added to both sides, and you would subtract it away. So that's subtraction property. Do you see the difference between the 2? Do you want to copy those down? Because you don't have that in your notes. Should I give you a second to copy it? So if you want to go to the back, you can copy this. If that's something that you think would help you, certainly do. and then I'll scooch down if you're copying that one too. Anyone still writing? Okay, let's go here. So here's a proof with angle bisectors. So let's copy down the given first. So we have that those bisect the given angles. Now, whenever you hear bisect, that means that that is going to cut that angle in half. So if Vx bisects WVY, what we can say then is WVX, and you want to make sure over here that that's the order that you put those in. So what we would say is angle WVX is congruent to, and now this next one